Okay guys, so today we're going to talk about inverse of functions. First of all, from Algebra 1, you guys should recognize that a function is a relation if there are no repeating x values. So let's look at these tables real quick and talk about if they're functions or not. So again, we're only looking at x values. Only looking at x values to determine if it's a function or not. So we've got -1, 0, and +1. Those are all different x values, so this table does represent a function. Over here, same thing, they're the same ordered pairs. You've got -1, 0, and +1, different x values, so yes, it's a function. And then same thing over here, you got -1, 0, and +1. So all these tables and these ordered pairs in this mapping situation, these do represent functions. Again, a function is a relation if there are no repeating x values. So let's talk about inverse of functions. An inverse of a function is a function that undoes the action of another function. So let's talk about back when you guys were in. So let's go back to this original slide. So we want to see when finding the inverse for tables, ordered pairs, and mappings, all we do is switch the x and the y values, and it's really that easy. So what we're looking at this week initially are just that, inverses of tables, inverses of ordered pairs, and inverses of mapping situations. So first, we should talk about how to denote the inverse. Inverse you'll always see as either y with a little -1. That -1 for the exponent represents the inverse. If you see f of -1 of x, that represents inverse as well. So you'll see us writing these y and these f of x values with -1 as an exponent, and that's how you guys will know that it represents an inverse. So let's take a look at this table right here. How would we get the inverse table? We just would draw another table. First, we would have x, and this would not be y, this would be y to the -1, and that would represent the inverse. And so all we need to do from here is just go in and just switch these ordered pairs. And so we're going to take -1 and 5, we're going to switch, it can become 5 and -1. 0 and 7 will switch, that becomes 7 and 0. 1 and 5 switch, and that becomes 5 and 1. So these two tables right here are inverses of each other, and all we did is just switch the ordered pairs. Okay, so for now for just an actual ordered pair, we're going to do just that. We're going to take these ordered pairs, we're just going to switch them. So it's going to become 5, -1. This one's going to become 7, 0, and this one's going to become 5, 1, and that right there, these two ordered pairs, these two representation of ordered pairs are inverses. So all we're doing is just switching x and y values when it comes to the inverse for these functions, and hopefully you guys see that it'll be relatively easy. I mean, students last year did really well with this concept. It's not a difficult concept, and so we just got to make sure that we understand all that. Only thing that we're doing are switching x and y values. We're not switching the signs of the x and y values. We're just switching the actual x and the y values. So for this situation down here, the mapping situation, all we would do, you would just want to write these ordered pairs out. So it's -1 and 5. Oops, hold on guys. So again, that's just -1 and 5. Because remember, this represents x and this represents y. Next ordered pair would be 0 and 7, and next ordered pair would be 1 and 5. So in order to get the inverse, all we do is we just switch these ordered pairs. So this becomes 5, -1. This becomes 7, 0, and this becomes 5, 1. So very simple to get the inverse. So we can do another example, and we'll ask, is the inverse a function or is it not a function? And those are the types of questions that you guys will see on tests. So let me give you guys, let's do a table situation here. So again, you're going to have x, and this is y. Let's throw some numbers in here. So let's look at this table. So we want to ask ourselves, does this table represent a function? So here, we're just looking at x values. So we've got -1 right here. I'm sorry, +1 right here, 0, and +1 right here. We have these two repeating x values of 1, and so this table represents it's not a function. Again, repeating x values, not a function. Now, to get the inverse of this, all we're going to do is we're just going to take these ordered pairs and we're going to switch them. Very, very simple. Again, we're just switching the actual ordered pairs. We're switching just the x and the y values. We're not changing signs or anything like that. This y to the negative first power represents the inverse. So from here, we're just going to switch the x and the y. It's going to become 5, 1. Switch x and y, become 4, 0. Switch the x and the y, becomes 3, 1. And then we go look at the x values, ask ourselves if we have any same x values. So I've got 5, 4, and 3. Those are all different values. So this table, the inverse table, does represent a function. So hopefully you guys see that this is relatively easy and straightforward. All you got to do is take x and y values, just switch them, and that's exactly how you find the inverse for tables, ordered pairs, and mapping situations. Have a good day. Algebra 1. Inverse function. So we were talking about what would undo something. So if I'm looking at an inverse function, you guys would have something like this. The 2 and the x are being multiplied. The inverse of multiplication is division, and so we would divide by 2 to get x equals 2. If we had this, what we would do is we would need to undo addition. So inverse function of addition would be subtraction. So inverses are addition and subtraction, multiplication, division, and you'll learn later in this unit other inverses are like squared and square root, cubed and cube root, and things